Hello there, and welcome. Tonight we're going to step outside, in our minds at least, away from rooftops and streetlights, and look up into a band of soft light that has been crossing the night sky since long before there were eyes to notice it. People have called it many things over many thousands of years. A river of milk poured across the heavens, a path walked by spirits, a long pale road leading home. But here we have settled on calling it the Milky Way. It is not simply a pretty smear of light. It is the galaxy we live inside, the vast and patient structure that holds our sun, our earth, and every person who has ever lived, all gathered together in one enormous, slowly turning home. There is something quietly comforting in that thought, and we will return to it more than once tonight. You're not adrift in empty darkness. You're held gently and without any effort on your part inside something so large that light itself takes 100,000 years to travel from one edge to the other, and so old that it began taking shape not long after the universe itself did. None of this needs your attention in any urgent way. It is simply here, the way the floor is here beneath your bed, the way the air is here around your shoulders. We are going to spend the next while wandering slowly through what we know about this galaxy of ours, drifting from one gentle fact to the next, with nowhere in particular we need to arrive. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. For now, there is nothing to do but settle in. Let your shoulders soften into whatever is supporting them. Let your breathing slow, just a little, just on its own. Let the day with all its small noises and small demands begin to fall away behind you, the way a shoreline falls away behind a boat moving slowly out into calm water. You do not need to hold on to any of it tonight. Let's begin. The Milky Way is, in the simplest terms, a galaxy, and a galaxy is nothing more or less than an enormous gathering of stars, gas, and quiet drifting dust, all held loosely together across unimaginable distances by the patient pull of gravity. It is easy to hear a word like galaxy and picture something distant, something belonging to textbooks and observatories, but this particular galaxy is not distant from you at all. It is the very structure you are resting inside right now, this evening as you lie there listening. Every star you have ever wished upon, every planet anyone has ever discovered, and the small warm world beneath you, all belong to this one vast and ancient system. There is a peculiar comfort in realizing that something so enormous is also, in another sense, simply home. From here, the story shifts to a small puzzle that troubled stargazers for a very long time. When you look up at the Milky Way from a dark field on a clear night, you see it as a faint, hazy band stretching across the sky, rather than as a great glowing wheel or a wide spiral spread out before you. The reason for this is a simple matter of where you happen to be standing. Our solar system sits inside the flattened disk of the galaxy, somewhere out toward its edges rather than at its center, and so when we look along the plane of that disk, we are looking through layer upon layer of distant stars, all overlapping into one soft river of light. It is a little like standing inside a great forest and looking along the row of trees rather than up at the canopy above you. You do not see the shape of the whole forest from where you stand. You simply see depth and light and the gentle suggestion of something much larger than yourself. There is something else worth considering here, something that has quietly slipped away from most of modern life. For nearly the entire span of human history, every person on this earth could walk outside on a clear night and see the Milky Way clearly, stretched overhead like a pale, soft-edged road. It shaped bedtime stories, calendars, and migration routes for birds and people alike. Today, because of how brightly our cities glow through the night, something like 80% of people in North America have never seen it at all. It is still there, every single night, exactly as it always was. It has simply been waiting behind a curtain of our own electric light, patient as ever, for the chance to be noticed again. Which brings us, gently, to the many names this band of light has worn throughout human history. The Greeks looked up and saw what they called Galaxius Kyklos, the Milky Circle, and it is from that old Greek word for milk that we eventually get the very word galaxy itself. Across the world, in the Sanskrit traditions of ancient India, this same pale band was sometimes described as a heavenly version of the Ganges River, flowing quietly overhead the way the sacred river flowed below. Many Aboriginal Australian traditions saw not a river but an emu, its dark shape outlined not by the stars themselves, but by the dark dust lanes drifting between them, a shy bird picked out in shadow rather than in light. In parts of East Asia, it became the Silver River, a wide and glittering waterway separating two lovers who could only cross to meet one another once a year. In Finland, some called it the Path of the Birds, the route that migrating birds were thought to follow each season. However different these stories were in their details, they share something tender in common. Every culture that looked up at this same pale band of light, separated by oceans and centuries and language, sensed that it was a path, a river, a road, some kind of gentle passage rather than a wall or a barrier. There is something lovely in imagining all of those different storytellers, in all those different centuries, quietly agreeing on this one small, hopeful thing. It is worth pausing here for a moment, before we travel any further, simply to let that settle. There is nothing you need to hold on to right now. Let your shoulders drop a little if they have risen toward your ears without your noticing. You are in no hurry, and neither is this vast, slowly wheeling galaxy we're exploring together tonight. Let us move on now to the question of just how large this home of ours actually is, because the scale of it is one of those things the mind can circle gently around without ever quite gripping all at once. And that too is part of its quiet appeal. Scientists estimate that the disk of the Milky Way stretches somewhere between 100,000 and 200,000 light years from edge to edge, and the fact that even professional astronomers describe it with a range rather than a single tidy number tells you something honest about how strange these distances really are. A single light year, the distance light travels in 1 year, is already almost too large to hold in the mind, something like 6 trillion miles. To cross the full width of our galaxy, light, which is the fastest thing in the entire universe, would need to travel for 100,000 years or more without ever slowing down. We are not built to feel distances like this the way we feel the distance across a room or down a hallway. We can only gesture toward them, the way you might gesture toward the size of the ocean while standing on its shore, knowing perfectly well that your arms cannot really show its true scale. And yet, beneath all of this almost incomprehensible vastness, there is something gentle about simply accepting that you do not need to picture it perfectly. You're allowed to let the number wash over you the way warm water might, without needing to hold its exact shape. The galaxy does not require your full comprehension in order to keep turning quietly around you. It has been doing that for a very long time already, long before you arrived, and it will continue long after, with no particular need for you to understand every detail. There is something restful in that thought, if you let it be restful rather than overwhelming. There is something else worth pausing on, which is simply how many stars are gathered inside that vast disk we have just described. Astronomers estimate that the Milky Way contains somewhere between 100 billion and 400 billion stars. And once again, that wide range is not a sign of carelessness, but of honesty. Counting stars across a structure this large, mostly hidden behind clouds of dust and gas, is a little like trying to count grains of sand on a beach at night using only a small lantern. We can study a patch carefully, measure how bright and how dense it is, and then extend that careful measurement outward across the whole shape of the galaxy. But some uncertainty always remains, and scientists are comfortable admitting that. Whatever the precise number turns out to be, it is large enough that if you tried to count one star every single second without ever stopping to sleep or eat, it would take you more than 3,000 years to reach the end. You do not need to count them. You only need to know that they are there, every one of them quietly burning while you rest. Let us move on now to something a little more intimate than the galaxy as a whole, which is the question of exactly where, within all of that vastness, we ourselves are actually sitting. Our solar system, with its sun and its 8 planets and its small rocky moons, sits roughly 26 to 27,000 light-years from the very center of the galaxy, out toward the edges of one of its great spiral arms, rather than anywhere near its heart. If you imagine the galaxy as a great spiral pinwheel, the kind a child might hold and watch spin in the wind, we are not at the bright central hub of that pinwheel, but somewhere out along one of its gently curving blades. This particular blade has a name, almost too modest for something so enormous, the Orion Arm, sometimes called the Local Arm, named for the constellation that happens to be visible in roughly that direction from where we sit. It is not even one of the galaxy's grandest spiral arms. It is something closer to a smaller spur or bridge, tucked quietly between two larger structures, the Perseus arm on one side and the Sagittarius arm on the other. There is a soft kind of comfort in that placement, if you let yourself feel it. We are not at the center of attention. We are out in a quiet, comfortable neighborhood, much like countless people feel about the towns and streets where they themselves have settled down to rest each night. From here, the story shifts to motion because nothing in this galaxy is actually standing still, however calm and fixed the night sky might appear to be from where you are lying right now. Our entire solar system is traveling in the long, slow orbit around the center of the galaxy, carried along at a speed of something like 500,000 miles per hour. That number sounds almost frantic when you say it aloud, and yet because the orbit itself is so enormous, it takes our sun somewhere between 225 and 250 million years to complete just one full circuit, a span of time astronomers sometimes call a galactic year. The last time our solar system was in this exact same position in its orbit, dinosaurs had not yet appeared on Earth. Continents were arranged into entirely different shapes, and yet from inside the slow, patient experience of being alive on this planet, none of that immense motion is something we ever feel directly. You're moving through space at a tremendous speed at this very moment, carried gently along by the same vast orbit that carries the sun, and you do not need to feel even the slightest tremor of it. You're simply being carried, the way a sleeping child is carried without waking, and all the way home. If your eyes are growing heavy now, that is perfectly fine. Let them close. The story will carry on around you, the way a familiar song keeps playing softly even after you have stopped watching the musician's hands. There is nothing here that requires your eyes to stay open. There is only the slow unfolding of one gentle fact after another, and you're welcome to simply listen, drifting wherever your mind wants to drift. Let us move on now to the actual shape of this galaxy we've been describing, because it is not simply a flat, featureless disk, but something with a quiet architecture all its own, built up slowly over billions of years. At its broadest description, the Milky Way is what astronomers call a barred spiral galaxy. The word spiral is probably familiar to you already, perhaps from photographs of other galaxies that telescopes have captured looking down from above, all curling arms and soft light, like a pinwheel caught mid-spin. The word barred is the more interesting addition. Rather than having stars spiral all the way down into a tight round centre, the Milky Way has a long, dense bridge of stars running straight through its middle, like the bar across the centre of the letter H, before the great curving arms branch outward from either end of that bar. For a long time, astronomers were not entirely certain our galaxy had this bar at all, since we cannot simply step outside and look down upon our own home from above the way we can examine a more distant galaxy. It took careful, patient measurement of how stars in the central regions were moving to finally confirm what now seems clear. We live inside a barred spiral, one shape among many that galaxies seem to favour across the universe. From here, the story shifts to the layers that make up this shape, because the galaxy is not one uniform thing but several different structures, nested gently inside one another like the layers of a great, slowly turning onion. There is the thin disk where most of the galaxy's younger stars live, including our own Sun, arranged in those graceful spiral arms we have already mentioned. Around and somewhat above and below that thin disk lies a thicker, puffier layer of older stars, appropriately called the thick disk, less tidy in its organisation, moving more loosely and at greater angles than the orderly thin disk below it. At the very centre sits the bulge, a dense, roughly egg-shaped gathering of mostly old reddish stars, packed far more closely together than anywhere else in the galaxy, and surrounding everything, far larger and far more diffuse than any of these inner structures, is the halo, a vast, nearly spherical region containing some of the oldest stars in the entire galaxy, scattered thinly across distances so great that the halo's edges blur into the surrounding darkness of intergalactic space. Each of these layers tells a slightly different chapter in the long story of how our galaxy came to be the way it is. There is something else worth considering about those graceful spiral arms themselves, which is that they are not quite as solid or permanent as they appear in photographs. For a long time, people assumed the arms were simply made of stars that stayed together, moving as a fixed unit the way the spokes of a wheel move together. It turns out the truth is gentler and stranger than that. The spiral arms behave more like a kind of slow-moving traffic jam, a pattern of density that stars pass through rather than ride along with permanently. Individual stars drift into an arm, slow down slightly as they pass through the more crowded region, and then drift back out the other side, while new stars arrive from behind to take their place in the pattern. The arm itself persists, glowing brightly because the crowding triggers new stars to form there, even though the particular stars making up its light are constantly being exchanged for others. It is a little like watching waves roll across the surface of the ocean. The wave shape moves steadily forward, clearly visible and consistent, even though the actual water making up each wave is mostly staying in place, simply rising and falling as the pattern of the wave passes through it. It is worth pausing here for a moment to notice how patient this entire system is. Nothing about the galaxy's shape was assembled quickly or carelessly. Every arm, every layer, Every gentle curve took hundreds of millions of years of slow gravitational settling to arrange itself into the shape it now holds. There is no rush anywhere in this story, and there does not need to be any rush in you either, right now, as you listen. Let us move on now to one particular oddity in the shape of our galaxy's disk, something astronomers only fully appreciated in recent decades. Rather than lying perfectly flat like a record resting evenly on a table, the outer edges of the Milky Way's disk are gently warped, rising up on one side and dipping down on the other, somewhat like the brim of a wide hat that has been slightly bent out of shape. Some researchers believe this warp may be caused by the gravitational tug of a few smaller companion galaxies that orbit nearby, gently tugging at our galaxy's edges the way a small child tugging at the hem of a tablecloth can send a slow ripple across its whole surface. It is a small reminder that even something as vast as an entire galaxy is not entirely isolated, but exists in a kind of quiet, ongoing relationship with its neighbours, nudged and shaped by forces from beyond its own boundaries. From here, the story shifts toward the very centre of all this structure, the dense and mysterious heart around which everything else, including our own sun, slowly turns. At the exact middle of the Milky Way lies a region astronomers call the Galactic Centre, and tucked within that region is something both small and almost unimaginably powerful, a supermassive black hole, which scientists have named Sagittarius A star, after the constellation in whose direction it happens to lie. You might expect something called a black hole to feel like a frightening idea, but there is no need for that feeling here. This black hole is not reaching toward us, and it poses no danger whatsoever to our solar system, tucked away as we are at such a comfortable distance, more than 25,000 light-years removed from its quiet gravitational hum. Rather than something to fear, it might be easier to think of it the way you might think of the deep, calm centre of a slowly spinning pool of water, the point around which everything else gently circles, doing its patient work of holding the whole system together through gravity alone. The discovery of this hidden heart did not happen all at once, but unfolded slowly across the 20th century, almost like the plot of a quiet mystery novel. In the early 1930s, an engineer named Karl Jansky, working not as an astronomer but as a radio researcher, trying to track down the source of static interfering with transatlantic phone calls, noticed a strange steady hiss of radio noise coming from the direction of the constellation Sagittarius. He had stumbled almost by accident upon radio waves coming from somewhere deep within our own galaxy, though he himself never fully realized just how significant that discovery would become. It would take several more decades, and the patient work of many other researchers using increasingly sensitive instruments, before astronomers in the 1970s finally identified a remarkably compact and powerful source of radio waves right at the galaxy's centre, the very signal we now understand to be coming from the immediate surroundings of that supermassive black hole. There is something lovely in imagining Jansky, decades earlier, simply trying to solve a small practical problem with telephone static, never suspecting that his careful listening would eventually lead humanity toward the quiet hidden heart of our entire galaxy. There is nothing you need to hold on to right now from any of this. You're in no hurry, and neither is this world we're exploring together. Let your breathing find its own slow rhythm as we continue onward, drifting now toward the stars themselves, those countless small lights that make up nearly everything we've been describing so far. Stars come in a wide range of colours, and that colour quietly tells us something true about each one's temperature. the way the colour of a flame tells you something about how hot it is burning. The reddest stars in the night sky are actually the coolest ones, relatively speaking, glowing at temperatures of a few thousand degrees, while the stars that appear blue or white to our eyes are the hottest of all, burning at tens of thousands of degrees and pouring out enormous amounts of light and energy in the process. Our own sun sits comfortably in the middle of this range, a yellowish star of fairly average temperature and fairly average size, which is part of why it has been such a stable, dependable source of warmth for the billions of years life on Earth has needed it to be. There is something quietly reassuring in that ordinariness. Our sun is not the most dramatic star in the galaxy, not the largest or the hottest or the strangest. It is simply steady, reliable, doing the same patient work day after day for longer than human history can easily measure. And perhaps that steadiness is something worth feeling grateful for, here in the dark, as you let it warm whatever part of your memory still remembers daylight. From here, the story shifts to something that might surprise you if you've always pictured stars as solitary points of light scattered evenly across the sky. Many stars are not alone at all. In fact, scientists believe that something close to half of all stars in the galaxy exist in pairs or small groups. 2 or 3 stars bound together by gravity, slowly circling one another the way dancers might circle a ballroom floor, sometimes for billions of years without ever drawing apart. From here on Earth, such a pair often appears to our eyes as nothing more than a single steady point of light, its true double nature hidden by the simple fact of distance. It is a gentle reminder that appearances from far away rarely tell the whole story, and that even something as solitary looking as a single twinkling star might up close turn out to be quietly accompanied. There is something else worth pausing on here, which is the existence of objects that very nearly became stars but never quite managed it. Astronomers call these brown dwarfs, and they form in much the same way ordinary stars do, out of collapsing clouds of gas drawing together under their own gravity, but they simply never gather quite enough mass to ignite the kind of sustained nuclear fusion that powers a true star's bright and steady glow. Instead, they smoulder quietly in a kind of permanent twilight, far dimmer than even the faintest true stars, slowly cooling across billions of years rather than shining brightly. There is something tender in the idea of these almost stars, scattered throughout the galaxy in numbers we're only beginning to estimate, each one having come so close to becoming something brilliant and settling instead into something quieter, something content simply to exist in its own dim and private way. Let us move on now to the question of where stars actually come from, because nothing in this galaxy that shines was always shining. Every star, including our own sun, was born out of something that did not shine at all. A vast, cold, quiet cloud of gas and dust drifting slowly through the space between existing stars. These stellar nurseries, as astronomers sometimes call them, are known more formally as molecular clouds, enormous gatherings of mostly hydrogen gas, laced through with fine dust and other elements, sometimes spanning hundreds of light years across. For most of their long, patient existence, these clouds simply drift, cold and dark and unremarkable, far too diffuse and too cool to do anything but sit quietly in the space between the brighter, busier parts of the galaxy. But occasionally some disturbance ripples through such a cloud, perhaps the shock wave from a distant exploding star, perhaps simply the slow accumulating pull of the cloud's own gravity, and pockets within it begin to collapse inward on themselves. As they collapse, they grow denser and warmer, drawing more material in from the surrounding cloud, spinning faster as they shrink the way a skater spins faster when pulling their arms in close to their body. Eventually, at the center of this slowly collapsing pocket, the pressure and temperature grow so extreme that hydrogen atoms begin fusing together into helium, releasing tremendous energy in the process. And a new star is born, blinking on for the first time after what might have been millions of years of quiet, dark gathering. One of the loveliest examples of this process happening right now, close enough for us to actually observe it in detail, lies within the constellation Orion, visible to the naked eye on clear winter nights as a faint smudge just below Orion's three-starred belt. This is the Orion Nebula, a glowing cloud of gas roughly 1,300 light-years away, lit from within by the fierce light of newly formed stars still nestled inside the cloud that birthed them. Telescopes peering into this nebula have revealed hundreds of young stars in various stages of formation, some still wrapped in their own dusty cocoons, others just beginning to clear the surrounding gas away with their own bright radiation, like a child just beginning to push back the blankets after waking. It is, in a very real sense, a stellar nursery still in active use, a place where new members of our galaxy's enormous population of stars are being gently, patiently assembled even as you rest here tonight. There is something else worth mentioning here, a particular photograph that became unexpectedly famous after a powerful space telescope captured it in the 1990s. Within a different stellar nursery called the Eagle Nebula, several thousand light-years from Earth, there rise towering columns of cool, dense gas and dust, each one several light-years tall, silhouetted dramatically against the brighter glowing gas behind them. Astronomers nicknamed these structures the Pillars of Creation, and the name has stuck ever since, in part because the image captures something so quietly beautiful. Tall, ghostly towers, each one likely containing infant stars still forming deep inside, slowly being sculpted and worn away by the intense radiation of nearby, already formed stars, the way wind and water slowly carve canyons out of solid rock. Whether those particular pillars still exist in exactly that shape today is itself an open question, since the light reaching our telescopes left them so long ago that we're really looking at a kind of ancient photograph, a moment frozen in transit across thousands of years of travel through the dark. There's something almost dreamlike in that thought, that what we see when we look outward is never quite the present moment, but always some gently aged version of the past, carried to us patiently across the years. If your eyes are growing heavy now, that is perfectly fine. Let them close. There is nothing here that needs watching closely. You can simply listen, the way you might listen to rain falling somewhere outside a window, present and gentle and asking nothing of you in return. Let us move on now to what happens after a star is born, because nothing in this galaxy stays exactly the same forever. And that includes every star quietly burning above you tonight. A star's life, however long it lasts, is really one long, slow balancing act between two opposing forces. Gravity is constantly trying to pull the star's enormous mass inward, collapsing it down toward its own center, while the outward pressure created by nuclear fusion in its core constantly pushes back, holding the star's shape steady against that inward pull. For most of a star's life, these two forces remain in a kind of patient, stable agreement, an arrangement astronomers call the main sequence, during which a star simply shines steadily for what can be millions or even billions of years depending on its size. Smaller stars, somewhat surprisingly, tend to burn their fuel far more slowly and patiently than larger ones, meaning the smallest, dimmest stars in the galaxy are often also its oldest and longest lived, quietly outlasting their larger, brighter, more impatient neighbours by enormous margins. From here, the story shifts to what happens once a star's fuel finally begins to run low, because nothing, not even something as steady as a star, burns forever without eventually changing. A star similar in size to our own Sun will, after billions of years of stable shining, begin to swell dramatically as its core fuel depletes, expanding outward into what astronomers call a red giant, growing so large that it might eventually engulf the inner planets of whatever solar system surrounds it. Eventually, having shed its outer layers gently into space in a great, slow exhale, what remains of such a star settles into a small, dense, slowly cooling remnant called a white dwarf. No larger than the Earth itself, but still containing roughly the mass of the original star, destined to simply cool and dim very gradually, perhaps for trillions of years, far longer than the universe itself has yet existed. There is something gentle worth noticing in this particular ending. A star like our own Sun does not end its life in violence or sudden catastrophe. It ends the way a long, full day might end, with a slow, graceful exhale, layers drifting outward into beautiful glowing clouds called planetary nebulae, painted in soft colours by the very elements the star spent its life creating, before settling quietly into its long, patient retirement as a white dwarf. There is no need to feel any unease about this. It is simply the natural, unhurried shape of a star's long life, unfolding exactly the way it always has, for star after star after star, since long before the Earth itself ever formed. There is something else worth considering, though, because not every star ends its life so gently. Much larger stars, many times the mass of our own Sun, meet a far more dramatic ending, though even here there is no need to feel any alarm, only a kind of quiet, distant wonder. When such a massive star finally exhausts its fuel, its core collapses inward with tremendous speed and then rebounds outward in an enormous explosion astronomers call a supernova, briefly outshining entire galaxies and scattering the star's outer layers across vast distances of space. From here on Earth, observed across safe distances of thousands or millions of light years, a supernova appears simply as a sudden new point of light in the sky, sometimes bright enough to be seen even during the daytime, before slowly fading again over weeks or months. Ancient astronomers across many cultures recorded such sudden new stars appearing without any obvious cause, and we now understand they were witnessing exactly this kind of distant, magnificent stellar farewell, happening safely far beyond anything that could ever touch us here. From here, the story shifts to what remains after such an explosion, because the core of a massive star does not simply vanish. Depending on exactly how massive the original star was, what remains might collapse down into an object called a neutron star, a sphere perhaps only 12 miles across and yet containing more mass than our entire Sun, packed so impossibly densely that a single teaspoon of its material would weigh, here on Earth, something like 1 billion tons. Some neutron stars spin rapidly, sweeping narrow beams of radiation around like a lighthouse as they rotate, and astronomers call these particular ones pulsars, because from Earth they appear to pulse on and off with remarkable clockwork regularity, some spinning hundreds of times every single second. There is something almost soothing in the image of a lighthouse, even one as strange and extreme as this, patiently sweeping its beam around and around through the darkness, marking out a steady, dependable rhythm across unimaginable distances, the way a real lighthouse might mark out a steady rhythm for ships passing safely somewhere far offshore. If the original star was massive enough, what remains after its supernova explosion might collapse even further than a neutron star, past every point where any known force can resist gravity's pull any longer, down into a black hole, a region of space where gravity has become so strong that nothing, not even light itself, can escape its pull. We have already spoken of the truly enormous supermassive black hole resting quietly at the very centre of our galaxy, but smaller black holes like these, formed from the deaths of individual massive stars, are scattered throughout the Milky Way in unknown but likely substantial numbers. There is no need to picture these as something hungry or threatening. Most exist in calm isolation, far from any other star, simply continuing to exist in their own quiet and dark way, doing nothing more dramatic than gently bending the space around them, the way a heavy stone gently bends the surface of a trampoline without anyone needing to fear it. There is something else worth pausing on here, something that quietly touches every single one of us, no matter how far away all of this might feel. When a massive star explodes as a supernova, it does not simply destroy itself. In its final violent moment, it forges new elements that could never have formed any other way, scattering them outward into the surrounding gas and dust that will one day gather together again into new stars, new planets, and perhaps new life. Nearly every element heavier than hydrogen and helium, including the carbon in your own body, the calcium in your bones, the iron carried quietly through your blood with every heartbeat, was forged inside the heart of some long ago star and then released across the galaxy by its dramatic ending. You're not separate from this story we've been telling tonight. In a very real and carefully measured scientific sense, you're made of stardust, assembled patiently over billions of years from material that was once part of stars that lived and burned and ended long before our solar system itself ever began to form. There is something almost unbearably tender in that thought, if you let yourself simply rest inside it rather than trying to fully grasp it. Whatever has been difficult about today, whatever thoughts have been circling in your mind, you are, underneath all of it, made from the same patient ancient material as the stars themselves. You're in no hurry, and neither is this world we're exploring together. Let your breathing settle into its own slow rhythm now, as we drift gently onward, away from the dramatic endings of individual stars and toward the older, quieter structures that have been gathering starlight for far longer than almost anything else in our galaxy. Scattered throughout the great spherical halo that surrounds our galaxy's disk, there drift roughly 150 tightly packed balls of stars called globular clusters, each one containing anywhere from tens of thousands to several million stars, all bound together so closely by gravity that from a distance they appear almost like single, very bright, slightly fuzzy stars, rather than entire miniature galaxies in their own right. These clusters are, in a very real sense, living fossils, among the oldest structures in our entire galaxy, often containing stars that formed not long after the Milky Way itself first began taking shape, more than 10 billion years ago. Looking carefully at the stars within a globular cluster is, for an astronomer, a little like a geologist examining the rings of a very old tree, or an archaeologist carefully reading the layers of an ancient excavation site. The stars themselves quietly record, in their colours and compositions, the conditions of the early universe in which they were born long before our own sun ever existed. One particularly lovely example, visible to the naked eye from the southern hemisphere, as a soft hazy patch in the night sky, is a cluster called Omega Centauri, the largest globular cluster orbiting our galaxy, containing something like 10 million stars packed into a sphere roughly 150 light-years across. Stand far enough south on a clear dark night, and you can look up and see this ancient gathering of stars with nothing more than your own eyes, a soft smudge of combined starlight that has been quietly orbiting our galaxy for longer than almost anything else we've discussed tonight. There is something deeply calming in the idea of something so old simply continuing on, unhurried exactly as it has for billions of years, asking nothing of anyone, simply persisting in its slow, graceful orbit. From here, the story shifts to a quieter mystery hidden within the orbits of these ancient clusters and the older stars scattered throughout the galaxy's halo. When astronomers carefully measure how fast stars and gas move at different distances from the galaxy's center, they find something that does not quite add up. Using only the gravity of the stars and gas, we can actually see and measure directly. Stars out toward the edges of the galaxy's disk are moving far faster than they should be able to move, given only the visible mass holding them in their orbits. If the gravity of visible matter alone were responsible, those distant outer stars should be moving slowly enough to drift away entirely, the way a child on the outer edge of a merry-go-round might fly off if the ride spun too quickly for their grip. Instead, they remain steadily, faithfully in their orbits, which suggests that some additional source of gravity, invisible to our telescopes, must be quietly holding everything together. Scientists have come to call this unseen material dark matter, and it is worth saying clearly that nobody yet knows exactly what it is made of. It does not emit light, does not block light the way ordinary dust does, and interacts with ordinary matter almost entirely through gravity alone, making it remarkably difficult to study directly. Whatever it is, current estimates suggest it makes up several times more of our galaxy's total mass than all of the stars, gas, and dust we can actually see combined, forming an enormous invisible halo that extends out even beyond the visible edges of the galaxy's disk. There is something quietly humbling in admitting this kind of uncertainty so plainly. For all that we have learned about our galaxy, for all the careful measurements and patient calculations that have revealed so much of what we have discussed tonight, there remains a vast, invisible portion of our own home that we still do not fully understand. Rather than feeling unsettling, there is a kind of gentle invitation in that unfinished quality, a reminder that wonder does not require complete answers in order to feel meaningful. There is something else worth pausing on here, something a little more delicate than dark matter, which is the presence of faint, ghostly streams of stars drifting through the galaxy's halo, the gravitational remnants of smaller galaxies that wandered too close to our own long ago and were slowly pulled apart by our galaxy's far greater gravity. One of the clearest examples is called the Sagittarius stream, a long, looping ribbon of stars that once belonged to a small companion galaxy, now being gradually stretched and absorbed into the Milky Way's own halo across hundreds of millions of years, the way a single thread might slowly unravel from the edge of an old, well-loved blanket. Our galaxy, vast as it is, did not simply form once and remain unchanged ever since. It has spent billions of years quietly gathering up smaller neighbours, absorbing them slowly and gently into itself, layer by layer, the way a life slowly gathers up its experiences, weaving each one quietly into the larger fabric of who someone eventually becomes. It is worth pausing here for a moment, simply to let all of this settle gently into place. There is nothing you need to remember, nothing you need to hold on to. You're in no hurry, and neither is this old, patient galaxy, still slowly absorbing its smaller neighbours after all this time, with no particular need to finish the process quickly. Let us move on now to the neighbours our galaxy still has nearby. the companions and relatives scattered through the surrounding darkness that have not yet been fully drawn in. If you have ever travelled far enough south to see a truly dark sky away from city lights, you may have noticed, low on the horizon, two faint cloudy smudges that do not look quite like ordinary stars, or even like the Milky Way's own hazy band. These are the Large and Small Magellanic Clouds, two small companion galaxies orbiting our own, visible to the naked eye from much of the southern hemisphere, named for the explorer Ferdinand Magellan, whose crew recorded them during their long voyage around the world. They sit at a distance of roughly 160 and 200,000 light-years from us, respectively, close enough, in galactic terms, to be considered genuine companions rather than distant strangers, gravitationally tethered to the Milky Way the way a smaller boat might be gently tethered to a larger one, drifting along together rather than separately. There is something else worth mentioning here, a smaller, quieter companion than even the Magellanic Clouds, called the Sagittarius Dwarf Galaxy, a small galaxy currently in the slow, ongoing process of being pulled apart and absorbed by our own galaxy's far greater gravity, the very source of that looping stellar stream we mentioned a moment ago. It is strange and rather lovely to consider that this absorption has likely been happening slowly and almost imperceptibly for hundreds of millions of years already, and will likely continue for hundreds of millions more. Far too gradual a process for any single human lifetime to ever notice directly. We live inside a galaxy that is still patiently growing, even now, even tonight, absorbing its smaller neighbours one gentle gravitational tug at a time. From here, the story shifts to a much larger relative, one that lies far beyond the small satellite galaxies orbiting close to home. Roughly 2.5 million light-years away, considerably farther than anything we have discussed so far tonight, lies the Andromeda Galaxy, a great spiral galaxy similar in size and shape to our own, and in fact the most distant object generally visible to the unaided human eye, appearing on a sufficiently dark night as a faint elongated smudge of light in the constellation that shares its name. When you look at Andromeda, the light reaching your eyes left that galaxy 2.5 million years ago, long before modern humans existed at all, which means you're not really looking at Andromeda as it is right now, but as it once was in some distant chapter of the deep past, carried patiently across the dark all this time just to reach you tonight. There is something quietly remarkable about our relationship with this distant neighbour, something astronomers have only fully understood in relatively recent decades. Andromeda and our own Milky Way are slowly drawing closer together, falling toward one another under the patient pull of mutual gravity, and current calculations suggest the two galaxies will eventually merge sometime around 4 or 5 billion years from now in a slow, gentle collision that will unfold across hundreds of millions of years rather than happening suddenly. Some more recent and extremely precise measurements have actually introduced a bit of gentle uncertainty into exactly how this future encounter will unfold, with a few researchers suggesting it might be more of a graceful near miss than a true head-on merger, though most still expect the two galaxies will eventually combine into one. Whatever the precise details turn out to be, there is no need for any concern here. Even in the more dramatic scenario, individual stars rarely collide directly during such galactic mergers, since the distances between them remain so vast even when entire galaxies overlap. It would look, from any surviving vantage point, less like a crash and more like two great slow rivers of starlight gradually merging into one even larger, slower river, continuing on together rather than apart. There is nothing you need to hold on to right now, Let your shoulders soften again if they have crept upward at all while we spoke of distant collisions that will not happen for billions of years yet. Longer than human history has existed, longer even than our own species has walked this earth. You're safe, resting quietly, while galaxies billions of years from now slowly continue their own unhurried business far overhead. Let us move on now to the long, patient human story of actually figuring out what this pale band of light overhead truly was, because for most of history, nobody knew, and the slow unravelling of that mystery is itself a rather lovely tale. For thousands of years, people gazed up at the Milky Way and wondered, without any way of finding out for certain what exactly they were looking at. Some imagined it as a kind of celestial smoke or vapour, others as a seam where the sky itself had been stitched together, others still as a road or river in the way we discussed earlier tonight. It was not until the year 1610 when an Italian astronomer named Galileo Galilei turned one of the very first telescopes skyward that anyone gained real evidence of what that hazy band actually contained. Looking through his simple telescope, Galileo discovered that the apparently smooth milky light was not smooth or vaporous at all, but was instead made up of countless individual stars, packed so closely together and so far away that to the naked eye they blurred into one continuous, gentle glow. It must have been an extraordinary moment, peering through that small instrument and realizing for the first time in recorded human history that the soft light overhead was not mist or smoke but an almost uncountable multitude of distant suns. From here, the story shifts forward roughly 2 centuries to the careful, patient work of an astronomer named William Herschel and his sister and close collaborator Caroline Herschel, who spent years methodically counting stars in different directions of the sky, attempting to map out the actual shape of the structure those stars belonged to. Using these careful counts, William Herschel proposed one of the first scientific models of our galaxy's shape. Though his estimate of its size, understandably limited by the instruments and methods available at the time, turned out to be considerably smaller than the truth eventually revealed by later generations of astronomers. There is something rather touching in imagining the Herschels, working night after night, carefully tallying faint points of light by hand, slowly assembling a picture of something so much larger than anything they could ever hope to fully measure with the tools available to them. Every great scientific understanding begins this way, with patient, careful counting long before the full picture ever becomes clear. There is something else worth pausing on here, a quieter contribution that turned out to matter more than almost anyone realized at the time. In the early years of the 20th century, an astronomer named Henrietta Swan Leavitt, working carefully through thousands of photographic plates at the Harvard College Observatory, noticed a reliable relationship between how bright certain pulsing stars called Cepheid variables appeared and how long their characteristic brightening and dimming cycle took to complete. This discovery, quiet and mathematical as it might sound, turned out to provide astronomers with an extraordinarily useful tool, a kind of cosmic measuring tape, allowing them to calculate the actual distance to any star cluster or galaxy in which such a pulsing star could be identified, simply by timing how long it took to brighten and dim. Leavitt's careful, patient cataloguing work, conducted largely without the public recognition it deserved during her own lifetime, would soon become essential to one of the most significant astronomical discoveries of the entire 20th century. Which brings us, gently, to a vigorous scientific disagreement that astronomers later nicknamed the Great Debate, held in the year 1920, when 2 respected astronomers, Harlow Shapley and Heber Curtis, publicly disagreed over a question that sounds almost unbelievable to us today. Was our Milky Way the entire universe, containing everything that existed, or were the faint, fuzzy patches of light known as spiral nebulae actually entirely separate galaxies, distant island universes of their own, far beyond the edges of our own? At the time, nobody had quite enough evidence to settle the question definitively, and brilliant, careful scientists found themselves on opposite sides of a genuine unresolved mystery. It is worth sitting with that for a moment. Less than 100 years ago, the basic shape and scale of the entire universe remained a genuinely open question, debated earnestly by the finest astronomical minds of the era, none of whom yet knew the answer. The resolution came a few years later, in the mid-1920s, when an astronomer named Edwin Hubble, using exactly the kind of pulsing Cepheid stars that Henrietta Leavitt's earlier work had made possible to measure, identified one of these stars within the faint spiral-shaped patch of light, known as the Andromeda Nebula. By carefully timing its pulsing cycle and applying Leavitt's relationship, Hubble calculated that this star, and therefore the entire spiral patch of light containing it, lay far beyond the boundaries of our own galaxy, at a staggering distance that placed it firmly outside the Milky Way altogether. In that single, carefully measured moment, the universe quietly and dramatically expanded in human understanding. The Andromeda Nebula became the Andromeda Galaxy, an entirely separate island of stars, and our own Milky Way, rather than containing everything that existed, was revealed to be merely one galaxy among what we now know to be an almost unimaginable multitude, scattered across a universe far larger and far stranger than almost anyone before that moment had dared to imagine. There is something quietly moving in tracing this whole chain of discovery back to its source. Leavitt's careful counting of pulsing stars on photographic plates, work that at the time received little public credit, eventually became the very key that unlocked the true scale of everything. If your eyes are growing heavy now, that is perfectly fine. Let them close, and let this whole long patient story of discovery simply rest quietly behind your eyelids, the way a favourite memory might rest there, available whenever you want to return to it, but asking nothing of you right now. Let us move on now to more recent chapters in this same long story, because the work of understanding our galaxy has never really stopped, and some of the most extraordinary discoveries have come only in the last few decades, well within living memory. In the year 2013, the European Space Agency launched a spacecraft named Gaia, sent not toward any distant planet or moon, but simply outward to a stable position in space, from which it could spend years patiently and precisely measuring the positions, distances, and motions of an extraordinary number of stars throughout our galaxy. By the time its various data releases had been carefully compiled and shared with astronomers around the world, Gaia had measured close to 2 billion individual stars with a level of precision previous generations of astronomers could hardly have imagined, effectively building the most detailed three-dimensional map of our galaxy ever assembled. There is something rather wonderful in picturing this quiet, patient spacecraft, drifting in its stable orbit far from Earth, doing nothing but carefully watching, measuring, and recording year after year, slowly assembling a portrait of our galactic home more detailed than any single human astronomer, however many lifetimes they were given, could ever have compiled alone. There is something else worth mentioning here, a quieter, more personal kind of exploration than a satellite's careful measurements. In the late 1970s, two small spacecraft named Voyager 1 and Voyager 2 were launched from Earth. originally intended only to study the outer planets of our own solar system during their relatively brief planned mission. Decades later, having long since completed their original assignments, both spacecraft continued onward, eventually crossing the boundary where the sun's influence finally gives way to the broader environment of interstellar space, becoming the first human-made objects to travel beyond our solar system and into the wider galaxy itself. Even now, both Voyager probes continue drifting steadily outward, carrying with them a small golden record containing music, languages, and sounds from Earth, a quiet message sent outward on the small chance that it might, someday, in some distant future far beyond any of our own lifetimes, be found by someone or something else. There is something deeply tender in that gesture. Two small, fragile machines, built by hand decades ago, still drifting patiently outward through the vast dark, carrying a simple greeting from home toward whatever quiet corner of the galaxy they might eventually, however unlikely, reach. Let us move on now to the question of just how old our galaxy actually is, because even time itself on this scale becomes something gentle and almost dreamlike to consider. The Milky Way is thought to be roughly 13.5 billion years old, having begun forming not very long in cosmic terms after the universe itself came into being. The whole universe, as best as scientists can currently measure, is somewhere around 13.8 billion years old, which means our galaxy is almost, though not quite, as old as time itself has been unfolding. The earliest stars within it were already shining well before our own sun had even begun to gather itself together out of its own quiet molecular cloud some 4.5 billion years ago, a process that, relative to the galaxy's full age, happened really only quite recently. There is something soothing in that perspective. Whatever feels urgent or pressing about your own day, your own week, your own small corner of time, it is happening within a structure so patient and so old that an entire human lifetime barely registers as a passing breath. From here, the story shifts outward, beyond even our own galaxy, to the company it keeps among its neighbours. The Milky Way belongs to a small gathering of galaxies astronomers call the Local Group, which includes our own galaxy, the Andromeda Galaxy we discussed earlier, a somewhat smaller spiral called the Triangulum Galaxy, and roughly 80 additional small, dim, dwarf galaxies, many of them satellites of either the Milky Way or Andromeda, all bound loosely together by their mutual gravity across a region of space several million light-years wide. And this local group itself is only a small gathering within something far larger still, a vast structure of galaxy clusters and filaments that researchers named, in the year 2014, the Laniakea Supercluster, a Hawaiian word meaning immeasurable heaven, chosen specifically because it captured something of the structure's almost incomprehensible scale, stretching across more than 500 million light-years and containing the mass of roughly 100,000 galaxies similar in size to our own. We belong, in other words, to a kind of nested set of homes within homes within homes, the solar system within the galaxy within the local group within Laniakea, each one larger and older and quieter than the last, holding everything gently inside everything else. There is something else worth pausing on here, a small comfort available to anyone curious enough to look for it. We cannot step outside our own galaxy to photograph its shape directly, the way you might step back from a building to see its whole facade. But we can study other spiral galaxies scattered at safe and patient distances throughout the universe, and use what we learn from them to better understand the shape of our own home. A galaxy called the Whirlpool Galaxy, visible through a modest telescope in the constellation Canis Venatici, shows us, from a fortunate angle nearly face-on, almost exactly what our own Milky Way might look like if some patient observer, far outside our galaxy entirely, were able to look down upon it from above. There is something quietly moving in studying a distant galaxy in order to better understand your own home, the way you might learn something true about your own life by listening carefully to someone else's very similar story. Let us move on now to a gentler, more intimate kind of star cluster than the ancient globular clusters we discussed earlier, one you may have actually seen yourself without quite realizing what you were looking at. On a clear autumn or winter evening, a small, tight cluster of stars called the Pleiades, sometimes known as the Seven Sisters, is visible to the naked eye in the constellation Taurus, appearing almost like a tiny, soft-edged smudge or a miniature dipper of faint stars huddled closely together. Unlike the ancient globular clusters scattered through the galaxy's halo, the Pleiades are what astronomers call an open cluster, a much younger, more loosely bound gathering of stars, perhaps only 100 million years old, all born together from the same collapsing molecular cloud and still, for now, drifting gently along together through space, though they will eventually, over hundreds of millions of years, drift apart entirely as the galaxy's gravity slowly pulls them in different directions. Nearly every culture with a clear view of the night sky noticed this particular little cluster and gave it its own name and story, from the Seven Sisters of Greek mythology to Subaru in Japan, whose name and stylized logo of 6 connected stars were both inspired directly by this same small, quiet gathering of young stars. There is something else worth considering now, something easy to overlook, which is that the space between stars is not actually empty at all, however dark and still it might appear. Scattered throughout the galaxy's disk, threading between every star and nebula we have discussed tonight, lies what astronomers call the interstellar medium, an extremely thin, mostly invisible mixture of gas and fine dust, far less dense than even the thinnest air here on Earth, but present nonetheless across every part of the galaxy. Our own solar system happens to be drifting, right now, through an unusually empty pocket within this medium, a region astronomers have nicknamed the local bubble, likely carved out hundreds of thousands of years ago by the shock waves of several ancient supernovae exploding nearby. There is something rather lovely in picturing our entire solar system, sun and earth and moon together, drifting quietly through this particular clear patch of space, like a small boat passing through an unusually calm stretch of an otherwise textured sea, fortunate enough, for now, to find itself in such gentle surroundings. If your eyes are growing heavy now, that is perfectly fine. Let them close, and let the rest of this drift over you the way the local bubble drifts gently around our own small, fortunate solar system, asking nothing of you, offering only its quiet company. Let us move on now to a few of the quieter, less visible forces that move through our galaxy, invisible to the eye but very real all the same. Throughout the disk of the Milky Way, faint magnetic fields thread their way between the stars, far weaker than the small magnet you might once have held on a refrigerator door, but spread across distances so enormous that their combined effect helps shape the very structure of the galaxy's spiral arms, gently guiding the way gas and dust drift and gather across the disk. Alongside these magnetic fields travel cosmic rays, extremely high-energy particles, mostly protons, flung outward by the violent deaths of massive stars and racing through this galaxy at speeds remarkably close to the speed of light itself. A small number of these particles are, at this very moment, passing harmlessly through the room around you through your own body, having travelled across the galaxy for thousands or even millions of years before finally arriving here, completing a journey of almost unimaginable patience, simply to pass quietly through this one ordinary evening of your life, entirely unnoticed. There is something else worth mentioning here. A clever method astronomers developed to map the hidden shape of our galaxy's spiral arms, even though visible light cannot travel far enough through the intervening dust to show us those distant regions directly. Clouds of hydrogen gas scattered throughout the galaxy naturally emit a very faint radio signal at a specific wavelength of about 21 centimeters, a signal that, unlike visible light, can travel largely unimpeded through the dust that would otherwise block our view. By patiently mapping where this particular radio signal is strongest and how its wavelength shifts slightly due to motion, astronomers have been able to trace the locations of distant spiral arms we could never have seen with visible light alone, effectively learning to listen for the shape of our galaxy rather than simply looking for it. It is a gentle reminder that there is often more than one way to perceive something true, and that sometimes patient listening reveals what careful looking alone cannot. In a similar way, the very centre of our galaxy, the region containing that supermassive black hole we discussed earlier, is almost completely hidden from ordinary visible light, obscured by thousands of light years of intervening dust and gas lying directly along our line of sight. It was only through the careful use of radio waves and infrared light, both of which pass through dust far more easily than visible light does, that astronomers were finally able to peer through that obscuring veil and study the galactic centre in any real detail. There is something quietly poetic in that fact, that the very heart of our home has been hidden from ordinary sight all along, visible only to those patient enough to learn to look using a different kind of light altogether. Let us move on now to one of the most remarkable shifts in astronomy to happen within recent decades, a change that occurred almost entirely within living memory. Until the 1990s, not a single planet beyond our own solar system had ever been confirmed to exist, despite centuries of careful speculation about whether other stars might have worlds of their own circling them. Beginning with the first confirmed discovery in 1995 and accelerating dramatically after the launch of a dedicated space telescope named Kepler in 2009, astronomers have now confirmed the existence of several thousand planets orbiting other stars within our own galaxy, with many thousands more candidates still awaiting confirmation. These distant worlds, scattered across our small corner of the Milky Way, have turned out to be far stranger and more varied than anyone fully anticipated. Enormous gas giants orbiting closer to their stars than Mercury orbits our own sun, small rocky worlds larger than Earth but smaller than Neptune, planets orbiting two stars at once, and worlds drifting in long, eccentric orbits unlike anything found in our own gentle, orderly solar system. There is something else worth pausing on here, a particular kind of question astronomers ask when studying these distant worlds, sometimes called the habitable zone, or rather more poetically, the Goldilocks zone, referring to the narrow range of distance from a star at which a planet's temperature might allow liquid water to exist on its surface, neither so close that any water would boil away, nor so far that it would freeze solid. A modest handful of the thousands of planets discovered so far appear to orbit within this gentle range around their own stars, and scientists continue patiently and without any particular urgency to study them more closely, searching for any further signs that might suggest the conditions for life as we understand it could exist there too. This naturally leads many people, astronomers and curious nighttime stargazers alike to wonder whether we might, somewhere among the 100 billion or more stars. You've been here long enough tonight. You can go now. Sleep well and good night.